Hello everyone, my name is Syed Asim Ali Warsi, and on behalf of my group, I'll be presenting today our presentation. We present here our presentation. Our topic is Tesla VPP project. So these are the contents of our project: introduction, project description, project evaluation. In the project evaluation, we have benefits, costs, data sets, project viability, and finally, we'll tell you some recommendations. So here I present you the introduction. So as you can see the picture, this is the picture of the VPP model. So in recent years, global energy is declining rapidly. Oil, natural gas, and other energy sources are also facing the problem of exhaustion. In addition, due to excessive exploitation of energy, environmental pollution has become increasingly serious. Among them, many power plants around the world are still using fuel to generate electricity, which greatly accelerates the consumption of energy. Therefore, it is necessary to develop a new way of power generation. The Tesla Virtual Power Plant as a new way of power generation will completely change these problems. Solar panels are used to generate electricity for families. In this report, we evaluate and analyze the principles and economic benefits of the Tesla Virtual Power Plant, and finally explain the advantages and potential of this project in the future. So further in the project description, the Tesla's Powerwall project is a follow-up to the company's battery system in South Australia. It started after the entrepreneur Elon Musk visited the country to learn about the hardship caused by its high electricity prices. The deal was jeopardized after the new government was elected in the state, but they eventually came around and committed to continue working with Tesla on the project. In 2018, Tesla started to deploy the first 100 Powerwalls in Australia as part of the virtual plant. The company also started grid services. The Tesla VPP project is a collaboration between the South Australian government and a company to build the biggest distributed energy resource network in the world. It will involve the installation of over 50,000 systems, and that will help manage the electricity grid and lower the cost of electricity for South Australians. So the research aims to verify the capabilities of VPP to deliver energy market services, and the three most important points are FCAS, which is frequency control ancillary services, reactive power voltage support, quick frequency response, and inertia are all examples of contingency measures. The initiative also tends to demonstrate the commercial viability of the South Australian VPP model, as well as its appeal to residential users. The South Australian VPP will save housing residents money on their electricity bills and improve the reliability of local grid. Through the project, the organization also hopes to create more jobs. Now further, I will tell you about the project evaluation. And under the project evaluation, I'll tell you the benefits of the project. So the project is divided on macro and micro level. On the macro level, we have stress reduction, CO2 reduction, more stability of the grid, and reduce dependency on dams, increase of air quality, and creation of new jobs. So further explaining this, uh, after our research, we got to know that multiple researches, such as the one done by Weiser and Palm in 2018, did cover the benefits implementing solar panels. Therefore, in alignment with what mentioned before concerning quantifying things and stepping out of engineering patterns, adding to all certainties, benefits were classified into two main layers, as I told you, macro and micro levels. Were At macro levels, the scope of benefits is wider, impacting governments, environment, and societies. while on the micro level, grid users and Tesla VPP users, for example, will benefit from this project. So on micro level, we have cheaper bills, return on investments, property value increase, remotely monitored, low maintenance, selling non-used energy, more efficient performance. So now I'll explain you the economics, the project costs. Uh, you can see the flow chart. I'll explain you. The main cost of the project were categorized into the initial cost of setting up the project and the project operating costs. The initial costs included the capital costs and the initial human resource costs. The operating costs that were considered to be ongoing throughout the project life were operating human resource costs. The main initial costs included the cost of equipment and technology, and the initial human resources costs included the cost of installation and setting up of infrastructure and project management costs. The main operating human resource cost included maintenance and upgrade costs, account management, and customer support costs. So further, in the project viability indicators, as you can see this graph, and as you can see that I is equal to 5%, which is the discount rate, and N is equal to 25 years, that is the project life. So on explaining this graph, the project benefits and costs were identified and quantified to develop the cash flow of the project, where the initial costs are assumed to be distributed evenly over the first 18 months. Based on a discount rate of 5% and project life of 25 years, the project viability indicators were calculated. Since the NPV is greater than 0, BCR is greater than 1, and IRR is greater than the discount rate, the project was deemed to be profitable from an economic perspective. This, however, is only based on chosen rate of discount of 5%. The feasibility of project can be determined by comparing the viability indicators to those of alternative solutions to the project, either through further analysis or benchmarking.
The main costs of the project were the initial costs and the operating costs. So the initial costs included the solar panel costs, the battery storage and other technology costs, as well as the installation, setup, and project management costs, where the operating costs involved the maintenance, account management, and customer support costs. The project benefits and costs were used to develop the cash flow of the project, where initial costs were distributed over the first 18 months. The discount rate that we used was 5% and the project life was 25 years. And from these, we were able to calculate the project viability indicators, which showed that the project would be profitable from an economic perspective.
In this project, we developed the data in which we define the data record, types of data, collections method, and the data is source. There are two types of data, primary data and the second data. The first data is sourced direct and the data that is collected by someone else and made a sixth is called second data. Second, data collection is project is mainly sourced from the government reports and other reports made public by power companies. The first data collection is made by surveys and focus group discussion. Data record for the project is financial data. The project's input and the preparation of residents.
So further, we would like to put some recommendations based on our research. First point is more data and specific analysis. The project is in the pilot project stage, so more data needs to be collected and specific analysis needs to be done to ensure the accuracy of the results. So the second point is establish regulatory mechanisms and information collection systems. This means that an excellent regulatory mechanism and information collection system is a significant factor in ensuring stable operation of virtual power plants, as they rely on information analysis and forecasting. And my final point is develop targeted policies to improve the operation mechanism. A series of incentives and subsidies for VPP and an improved operating mechanism can ensure the development of VPP and significant revenue growth. So here I would like to end my presentation and like to thank you for listening to us patiently on behalf of my group. Thank you so much.